Today we're going to talk about, from section 8.3 in our textbooks, 0 and negative exponents. So we had a quick warm-up here, simplifying an expression. Note that something squared is just that times itself. Negative 3 times negative 3 is 9. X times x is x squared. We also saw earlier in the unit that if we have an exponent applied to a quotient, then we can more or less distribute that, and we can get a to the third to the fifth and 2b to the fifth. And we saw powers of powers multiply exponents, so we have an a to the 15 on top. And then down below we have a 2 to the fifth, which is 2 to the fifth, and b to the fifth, and 2 to the fifth is 32. So we've come up with properties from the definition of exponents before, up in the previous two sections. So we're going to kind of do the same with 0 and negative exponents here, and they're going to come from division. So let's take an example problem here, and then we'll come up with a rule for these two things. So how about we look at how about 3 to the second power? Actually, I'll change this. 3 to the fourth power over 3 to the fourth power. And let's use our exponent rules to come up with, to like rewrite this out. So 3 to the fourth is really the same as 3 times 3 times 3 times 3. And 3 to the fourth also is 3 times 3 times 3 times 3. And since we have factors that are like on top and bottom, we note that 3 divided by 3 is 1. 3 divided by 3 is 1. Divided by 3 is 1. Divided by 3 is 1. So this whole thing ends up being 1 times 1 times 1 times 1, which is exactly 1. Well, using our division rules from our previous section, we have saw that if you have the same base and same base, then you can subtract the two exponents. So this, using our exponent rules, is really 3 to the 4 minus 4, which is 0 power. So what we see is from the same expression, we get two different things. We get, by expanding out and dividing, you get all the 3's cancel out and you get 1. Or if you use your exponent rules, you get a 0 exponent. So what this is really saying is that these two things are really equal to each other. Or in fact, our rule here is that anything to the 0 power is 1. Whether it's a variable, whether it's a constant, anything to a 0 power is always 1. Okay, so let's look at negative exponents. So how do we get those? Well, they commonly come up when you see problems like this. How about, like, we'll use variable this time, x to the third power over x to the fifth power. So let's take this expression and let's write it out kind of like we did over here. So I'm going to expand this using definition of exponent. So this is the same as x times x times x. And the denominator is x to the fifth. So x times x times x times x. And again, like before, those two, x divided by x is 1. Something divided by itself is 1. Something divided by itself is 1. So now what do we have? Well, we have 1 times 1 times 1 on the top, which is 1. And we have, let's see, 1 times 1 times 1 times x, which is the same as x squared. Okay. Well, let's play the same trick with our, let's now evaluate this using our exponent rules. Same base, division, but connecting them, so we'll subtract the exponents. This is x to the 3 minus 5, which is x to the negative 2. Okay, notice how these are connected. We have a base to a negative exponent, but that's still the same as 1 over x to that same over that base to the same exponent, just now it's positive. So what this is telling us is that a negative exponent is really just another way to write a reciprocal or a flip. So to recall this, so to kind of put this in words, this relationship, then this is saying that negative exponents tell you to flip the base to the other side of the fraction bar and make the exponent positive. Right? Because we can always turn this into a fraction by putting it over 1. So if I flip it down below and change it to a positive, I get 1 over x squared. So let's see some examples of this. Okay. Use the definition of 0 and negative exponents here. So 6 to the negative 2, that should be the same as flip to the other side of the fraction bar and make the exponent positive. So that should be the same as, since we flip this down to the bottom, we'll leave a placeholder for, since there's nothing left there, we'll leave a placeholder. So this is the same as 1 over 6 to the positive 2, and 6 squared is 36. Okay, anything to the 0 power is 1. Okay, so let's use our exponent definitions here. So let's see, as we did yesterday, or in the previous section, we saw that a power of a quotient, we can distribute that out. So we can do 2 to the negative 2 over 3 to the negative 2. Negative exponents, they flip. So that means since this is a negative exponent, I'm going to throw it to the bottom side of the fraction bar. And since this guy's got a negative exponent, I'm going to throw him in the top side. So I'll do both of those, and now I'll give myself positive exponents. Okay, so I flipped it, and then the exponent positive. And now I can figure out what 3 squared is. 3 squared is 9, 2 squared is 4. Okay, 0 to a negative power here. So again, this is like 0 over 1. So 0 to the negative 7 is the same as flip him. You can say 1 over 0 to the positive 7, which is 1 over 0. Unfortunately, dividing by 0 is not allowed. It's not only like nothing, it's nonsense. In fact, this is an undefined quantity. It's not even a number. It's not even a thing. It's just not allowed, period. Okay, on the second page of the note sheet here, we'll evaluate some exponential expressions here. So I have the same base. When I multiply the same base, that means I can have that base to the powers added together. So 5 plus negative 5 is 0. Anything to the 0 power is 1. Powers are multiply, so this should be 3 to the negative 6, which is the same thing as 1 over 3 to the positive 6. Okay, negative 8 to the negative 2. Negative exponent means I can flip it to the other side of the fraction bar. So this is really 8 to the positive 2 over our placeholder 1. Note that anything divided by 1 is just itself, and 8 squared is 64. Okay, 7 to the third over 7 to the fifth. So if I use my exponent rules, I have same base and dividing, so I can subtract the exponents. 5 minus 3 is negative 2. See, negative exponent means I can flip this or find the reciprocal of this. This is 1 over 7 to the positive 2, which is 1 over 49. Okay, let's do some more relatively more complex expressions. Okay, so I have I have a product here, all raised to another power. So as we saw on section 8.1, we can distribute this exponent to everything. So this should be 3 to the third, x to negative 2 to the third, y squared to the third. Simplifying these, 3 to the third is 27. X to the negative 2 to the negative 3 is x to the negative 6. Y squared to the positive 3 is 2 times 3 is 6. My directions say, though, I can only write positive exponents, so that means I got to fix something here. Well, this is, again, if this was an expression, I could put over 1, because there's no fraction, I can make it a fraction. Negative exponent tells me to move the base to the other side. Note this negative 6 is only going attached to the x. It's not attached to the other things. So that means I'm going to take my base that has a negative exponent, and I'm going to flip it to the other side of the bar, but make the exponent positive. So my answer here is going to be 27, y is 6. And now, since x used to be negative, now I'll make it positive by putting it down below. When I start with two products, so my final example here, when I start with two products, when I start with two products that are being divided, note there's no addition or subtraction. I have all multiply and all multiply. One strategy for me is to separate these into fractions based on the basis. So what I mean by that is I'm going to take the coefficients and make a fraction. Then I'm going to take all the things with x as a base, and all the things with y as a base. Now I'm going to simplify each of these fractions separately. So 4 over 8 reduces to 1 over 2. X to the negative 2 divided by x, remember there's a hidden 1 here. It could be x to the negative 2 minus 1, which is really x to the negative 3, times y to the 4 minus 6, which is negative 2. Okay, I don't want negative exponents, so I have the 1/2. X to the negative 3 is same as 1 over x to the positive 3. Y to the negative 2 is same as 1 over y to the positive 2. My final step here would be to recombine these into one fraction. And when I multiply fractions, I just multiply all the way straight across. So 1 times 1 times 1 is 1 in the numerator. 2 times x to the third times y squared is just that. 2x to the third y squared.